Welcome back to Dish and DAS Administration 1, FR-100. My name is David, and I will be your instructor for this learning module. In Module 2, you will learn some frame platform concepts. After a brief overview of end-user computing, I will explain how the frame platform makes uses of an entity hierarchy to organize and group your integrations and workloads. This module will also introduce you to some of the terminology you will encounter in later training modules. End-user computing. EUC is an umbrella term for a list of products that are designed for day-to-day computer users. There are three categories that are relevant to how a remote user gains access to remote applications. Virtual desktop infrastructure is a legacy method of delivering desktops by running a desktop operating system, typically Windows, on a virtual machine platform such as KVM, VMware, or Xen. Additional software helps enable this capability, such as connection brokers and display protocols. In this model, users are typically mapped one-to-one to a VM, and the applications are installed on these same virtual machines. The VDI management software is typically installed alongside the same software that administrates the virtual infrastructure. In contrast, server-based computing, or remote desktop session host, RDSH, is a model where multiple users connect simultaneously to a shared VM. The application often must be multi-user capable, and the scalability is dependent on the resources available on the shared virtual machine. This model is very common with Citrix XenApp or terminal services. Desktop as a service is a cloud-based model that simplifies management and delivery of the desktop and applications by utilizing hosted management software combined with the flexibility and scale of cloud providers such as Amazon AWS or Google Compute. DAS offers several major advantages over legacy VDI and RDSH. When it comes to planning your desktop rollout, there are two models you should consider specifically. The first model is placing your applications close to the end users. Users on VMs at longer distances from data or application services will have a better streaming experience, lower latency, but may experience longer delays opening and saving files, where the latency is in accessing file servers at a corporate office. In addition, the users may experience that client-server type applications are sluggish when retrieving data due to a higher latency between client apps and data sources or services. The second model places the applications closer to the data. In this scenario, users on VMs at longer distances from data or application services will have a diminished streaming experience due to higher latency. However, these same users may have less delays opening and saving files due to the shortened distance of the VM to the file servers at the office. Users likely will experience client-server type applications as being more responsive. In this section, we will begin to explore how the frame platform is organized. The terminology described will be important for you to learn as you plan and manage workloads on the platform. Dish and DAS Cloud Platform is a hosted, multi-tenant, and multi-region solution. Compared to traditional VDI, there is no server software, database, or other management tools for you to install and keep updated. The platform is automatically updated with new features and bug fixes on a regular basis, ensuring security and reliability, with no need for maintenance windows or downtime. All of the necessary services, including the cloud gateways, connection broker, dashboard, and launchpads, are fully managed, highly available, and auto-scaled by Dish. For customers using on-premise infrastructure, only a Cloud Connector appliance is required to facilitate orchestration of the workloads. Note that while our platform is multi-tenant, customer workloads and data are always segmented and isolated as per compliance requirements. Perhaps one of the most important constructs of the frame platform is the entity hierarchy. At the top level is the customer. All other objects belong to the customer entity. Here, you can set global settings, cloud accounts, and identity. Adding these objects here means that all child entities will inherit or have access to these at their sublevels. The next level down is the organization. You can add multiple organizations within a customer. An organization is typically used to segment departments or geographical regions. Some larger enterprises or MSPs may have subsidiaries or other customers they wish to identify as a separate organization. Organizations can also have their own cloud accounts and identity provider. When added at this level, only the organization in which they were created can use that cloud account or identity provider. This can be useful when you need to separate compute resources or billing for chargeback or showback, or if you are hosting multiple tenants under your customer account. Lastly, the account entity is the frame account. This is the object that defines the workload, holds the template image, defines the launchpad, and configures the behavior and capacity of the desktop pool. Identity provider integrations determines how your administrators and end users will be granted access into the platform and to which objects they are granted authorization based on assigned roles. You can use one or more identity providers. Remember, where you add the identity provider within the hierarchy will determine which context the users and roles are available to be assigned. Adding to the customer level makes the identity available to all organizations and all accounts within those organizations. Adding the organizations level makes the identity available to only the frame accounts that belong beneath that specific organization. Lastly, adding the identity to the individual frame account makes it only available to that desktop pool. Basic authentication allows you to create users within the frame platform. These are tied to an email address, and the passwords are stored securely in a database. This option is typically only used as a failsafe for system administrators to access the frame control panel, in the unlikely event your SAML2 provider is unavailable. Other options include using Google or any other SAML2 compliant software such as Okta, Entra-ID, Keycloak, or Duo. Note that while you can configure more than one identity provider, authentication treats each login separately. This means that if you have the same person, even with the same email address stored in two different providers, Frame will treat users in each provider as a unique person. In other words, if Bob Johnson logs in from Entra-ID, he will be considered a different person to Frame if he logs in using Okta. We will dive deeper into identity providers in a later lesson. Frame supports running workloads on multiple cloud infrastructure providers. Cloud accounts can be added to the customer or organization levels. If you wish to separate your workloads for business or financial reasons and assign them to specific departments or office locations, then you should assign the cloud provider account under an organization instead of at the customer entity level. You can add multiple cloud accounts at either level. A frame account is where the workload desktops live. Frame accounts belong under the organization level. On creation, you will select from available cloud accounts that are configured at the organization or globally from the customer level. You must also select if the account type is to be persistent or non-persistent. We will explain more about these two account types in the next module. Each frame account has a sandbox or golden image. This is the virtual machine template that defines the rest of your workloads. It is where you install and manage the operating system and applications that are available to your end users. Frame Remoting Protocol 8, FRP8, is Dishon's proprietary remote display protocol. It makes use of the industry standard WebRTC for maximum compatibility with modern browsers and end-user devices. By default, FRP8 uses UDP as the transport layer. Version 8 offers significant improvement in features, capability, reliability, and application compatibility when compared to other protocols. Throughout this course, you will likely hear me mention other acronyms or terms specific to DAS. I won't cover them in depth here, but this is a short list of some of the more common components, actions, and objects. Alright, so that's it for this module. Let's take a minute to review what we learned. DAS and VDI are subsets of the end-user computing classification of software. We looked at two deployment models for placing applications either close to the user or close to the data. We also learned that Frame is Dishon's cloud-native DAS solution. The platform organizes entities into a structured hierarchy where cloud accounts, identity, and frame accounts are nested to provide desktop services to users who access the machines using the Frame Remoting Protocol, FRP. This concludes the lesson module. Be sure to check out the other videos in the series that make up the full course. Thanks so much for watching.